Hey, hello, welcome to the show. It's me, John Park, and it is time for JP's product pick of the week. And it's time for me to adjust this camera a little bit. How you doing? Thanks for stopping by. Thanks everyone for jumping in over on our various chats. We've got the YouTube chat over there with Robert Cochran, hello, and Beata, who's changed their username, Graf Avdelhagen, or why is my thing showing, my YouTube is showing handles and not names? I don't know. Hello to Robert Cochran, Dave Odessa, CRHEES, Johnny Bergdahl, hello. Yeah, it's using what's the word for that? Like handles on the YouTube chat. I don't think I used to do that. We fear change. And then, of course, we've got our Discord chat. So if you're wondering where the chat is at and you're somewhere else, you can head over to adafruit.it/Discord. Jump into the live broadcast chat channel on our server. Hello there to Johnny Bergdahl and Duwester, Sam J. Ohio. Hey, Byron, greeting from Nevada. And Blitz City DOI. Hey, Liz, nice to see you all. So, excuse me, what's going on here? Let me point you at that. That is the URL for this week's product pick. That is the QR code if you like that sort of thing. Head on over there. And you will find that this show is being broadcast inside of the product page. We had 50 of these stashed. Again, this was one that we didn't have a ton of, but we wanted to feature, so we were able to stash 50 of them. So there are just a few over 50 in stock right now. Half price, no coupon code necessary for the product pick show. You just get it at the very cool half off price. That's what you do. Throw them in your cart, up to 10 per customer, no resellers allowed, and run off with them. It's a steal, run off with them before the end of the show or before they sell out. That's how you do it. Over in the chat, Beata Graf Avdelhagen says that it's been doing that on and off for a couple of months at least, not every chat too. Weird. Unnerving. And Robert Cochran says, please call me Bob. Okay, Bob. Hi, Bob. So head on over there, check it out. Before I say any more, this is a product that came out a while back. Then it went kind of ballistic during the pandemic. The pricing got wild. We had to raise the prices quite a bit. Then we were able to drop them back down. We've just come out with this latest version that has just a slight parts change. And Lady Ada will tell you all about it. So take it away, Lady Ada.
Yes, finally the STM32F405 Feather is out. We had signups, we notified everyone, and we sold out. But we're making more. It's fast. We made like 200, and they went fast. This is our star new feather. It is, as we said, the STM32F04. It's a 168 megahertz Cortex M4 from ST. It's our first ST micro feather, and it's got some nice goodies which I'll show off. First off, it's a feather, so it's feather compatible. It's 3.3 volt logic. It has all the pins.
ST takes flight.
It takes
this
flight.
This headline writes itself.
There's two DACs, A0 and A1. Lots of ADC, so A0 through A5 are ADC. You've got SPI here, I2C, UART. There's no AREF on this pin, so you get two 3.3 volt pins. I'll zoom in a little bit here. Ground, reset pin, enable battery, which is the battery voltage, USB, which is the 5 volt from here. Digital IO, 5, 6, 9, 10, 11, 12, 13. Of these, I think the first 4 have PWM. Actually, the only pins that don't have PWM pretty much are a couple of the ADC pins and 11, 12, 13. I2C as well. We put a 2 megabyte SPI flash chip on here, so for CircuitPython use or for everyday use if you want to access a bunch of memory on chip without having to plug in an SD card. It's 2 megabytes on there. And then we had a little space over here, so we put a quick STEMMA QT connector. And so, for example, here's an upcoming little mini GPS, which has I2C connectivity. And you see here, this is our classic OLED feather wing on top here with buttons, and it's printing out the output from the GPS. There's no connectivity inside here, so you can't see the location, but you can see data coming out. in the GPS. There's also a NeoPixel reset button, circuitry, 3.2 kilohertz, 32.768 kilohertz crystal, 12 megahertz main crystal, which is used to clock it up, and then charge LED and pin 13 LED. And I'm going to unplug this to show off the bottom. On the bottom, we have a SD card, and the SD card is connected to the SDIO lines. And we also have a non-placed SWD connector. So to program this, we recommend using the boot 0 method, which means you take the B0 pin, connect it to 3.3 volts, which is like over here, press the reset button, and it'll boot into the built-in ROM bootloader, which has USB DFU, and that's really easy. So it's a great way to upload MicroPython or CircuitPython or even Arduino to it. But some people like to program through SWD, in which case you'll have to either solder on this connector or solder to these tabs to get access to SWD. We did not bring out the SWD pins because I think most people are going to use the built-in bootloader, and for CircuitPython and MicroPython, you pretty much never have to upload. So much fast, so data. And yeah, so for this you can use CircuitPython. We have some basic support going for CircuitPython. Not absolutely everything is supported, but we have digital I/O, SPI, I2C, UART, analog, and input and output. We're still working on UART, and PWM is still a little bit in progress, so that's very exciting. And then you can use with MicroPython because it's the same chip as the Pi board. So if you check it out, we have submitted a PR to MicroPython to add support for this chip. You can also use it in Arduino. We have also a PR to STM-Duino for support for this chip, and it actually works pretty well. STM-Duino, almost everything we tried worked out quite well with it. The only thing it doesn't have yet is auto reset for the bootloader, but that's an open issue, and they'll hopefully fix that soon. So this is a little bit early for this Feather. I'll say it's not great for people who this is their first Feather. This is for people who are like, oh, I've used Feather, I've used microcontrollers, I'm kind of comfortable with the different ways that you program them, and I would like to try out the STM32.
I'd say if you're really into something like MicroPython, but you like the Feather form factor, this is for you.
This is good, or if you really just want 168 megahertz. This is our fastest Feather. It's faster than the SAMD51. And if you want to use this with STM32 IDE, the Cube IDE, and get direct access to the STM HAL, this is also an excellent platform because a lot of people tend to use the Nucleo or Discovery boards, and they're amazing and they're great, but they're not Feather compatible. And with this, you get plug and play support with Feathers and with Quick and STEMMA QT.
That's right. That is it right there. The product pick of the week this week is the Feather STM32 F405 Express. So this is a whole bunch of microcontroller in one little package. It is your typical Feather goodies. So it's the pin compatible with almost all the Feather wings and other accessories. It has USB-C on it, which is very nice. It has LiPo battery charging, so USB-C is for data and power. LiPo battery charger built on board NeoPixel, tons and tons of GPIO. A couple of special features. This has a STEMMA QT port on it. It was the first Feather that had that, so you can plug in all your I2C accessories over that using STEMMA QT/Quick. On the bottom, this has the micro SD card reader, so you can use that. It is over SDIO, so it's quite fast, and we've got support for that in CircuitPython. We have support for this actually in CircuitPython, Arduino, and MicroPython, which is not typical for these Feather boards, but since this one is the same chip that's on that Pi board 1.1, I believe it is, we submitted, and there was a PR accepted to make a board definition for this in MicroPython. I've actually got MicroPython running on this one right here. I'll show you that in a moment. Some other facts about this. So this has two 12-bit DAC pins, so you can do audio out. Has 6 12-bit ADC pins, so read analog. I2S CAN built right on board. SPI, UART. There are a bunch of PWM pins. It has a DFU bootloader. So the device firmware update bootloader, I just use DFU util in the command line on my Mac. You can do that on Linux as well. I'm not sure on Windows. I think there's an application instead. But you can upload your hex or DFU or bin files to this of MicroPython or CircuitPython. And you've also got on the bottom pins there for, in fact, let me bring up some images of this. So you can see on the bottom there, those little tinned SMD pads there. Those are for an SWD header in case you want to plug in a programmer. So rather than using the DFU uploader, if you're doing more debugging or more frequent updating, you may want to solder on that little header. And we have that listed on the page right here. So there's the main page, and included here are some links for things you might want to add to your cart. There's the SWD 0.05 pitch connector, 10-pin SMT box header. So you can solder that on, and then you'll be able to use a programmer. Someone asked in the chat, I'm not going to demonstrate that today. I've done that before on other boards, not on this one, this exact board, but this was very easy to program using the DFU updater. What else? We've got onboard NeoPixel there for indicator. There's a pin 13 LED for blinking and also just kind of checking that things are working or any other indication you want. And let's take a look at a couple of other things on the page. So before I move ahead, let me swap over. There is our live ticker. So you can see there's the price on it, $12.48. So that's great because this went up to, if I'm not mistaken, I think this was $39 and change during the pandemic when the price of that STM32F405 chip went through the roof. It was like $15 cost to Adafruit to get that. So the board became very expensive. That price has dropped down, as Lamore was saying, closer to like $5. So we've got the price down to $24.95 for the Feather, which isn't bad, but during the show right now, $12.48 is a steal. So go throw some of those in your cart and maybe buy them before the show is up so they don't all disappear on you. A couple of other things from this page. If you scroll down a bit, there are some of those facts that I read out, including, I forgot to mention, this is a pretty fast chip, 168 megahertz speed. It's a Cortex M4. It has floating point. It has a meg of flash. We have 192K of RAM available. And as Lamore had said, this was the fastest Feather at the time. I believe that's been eclipsed now by the ESP32S3 running at like 240 megahertz. So that is a faster chip. But depending on your needs, this with the Cortex M4 may be what you're looking for. If we keep scrolling down, a bunch of little videos there, some previews of it. There are some guides. So primary guide right here, if you take a look, you'll get the pinout page here. I'll show you all the different pins and their assignments, what they can be used for. If you take a look here, we've got Arduino IDE setup, MicroPython setup, and CircuitPython setup, as well as some details on using the DFU bootloader. So let me show you a CircuitPython example. I'm going to drop down. I'll show you what I'm looking at right here. There is STM32F405 Feather. I have it plugged into USB-C for power and data. You can see the NeoPixel on here is glowing and doing things. I have a light shining on there that I can move a little bit. There you can see it's green right now. It's going to flash to blue when we write data to the SD card. So I've got a micro SD card plugged in there, and I am logging data. The data I'm logging is the CO2 humidity and temperature coming off of this SC041 sensor breakout that I have plugged in using I2C over Stemma QT. So this is right now considered a healthy, low level of CO2. It's actually lower level in here in my workshop than it is in my office because it's a bigger space, a little draftier. If I breathe on it, I'm gonna get close on this. I'm gonna breathe on it. we'll see in a moment it should start to go into the yellow or red range. Let me get a little more CO2 on there. There we go, yellow. So I think I have that over 1,000 parts per million is going to go yellow, and it's going to take a little while to clear out there. I didn't saturate it, so it hasn't gone red. But we can see that data in real time right here. So let me go over to my REPL inside of Z. You can see CO2 is 2,286 parts per million. There's the temperature, 21.3 degrees centigrade, humidity. So what I want to do, let me see if I can fan that a little bit to try to move some air around. Get that out of the yellow zone and into the healthier green zone. There you can see it's dropping. And in fact, let me turn on a fan in the space. It'll bring in some air from outside. There you go. That's not going to blow directly on this, but that should adjust our level. So keep an eye on that. Now, what I'll do is I'll risk everything. I'm going to wait for it to blink blue, which is when it tells me it is writing to the SD card. And then I'm going to pop that SD card after the next write, which is every 5 seconds. Okay, so I pop this card out. There you can see I've got my little card on there. I'm going to plug this into an SD card reader on my computer. And then right here in the same code editor, I'm just going to open the SD card sensorlog.csv. And here you can see, now I'm not doing any time stamping on here or anything. I could. You could also add a real-time clock to this using one of our little breakouts with a battery on it. But here you can see the sort of story of being inside my office, hovering around 1,000, me breathing on it at some point and getting up to 3,000, it calming down, coming here into my workshop. It's nice and drafty in the 600 parts per million. Here's where I breathed on it at some point. Should be right here. Yeah, this is just now when I breathed on it. So this was 600s until I breathed on it, and now we get up into the thousands again. So pretty cool that you can do this with the SDIO built-in SD card reader. Let me go ahead and turn off diagnostics here. And you can see this is the code we're using. So I've got my sensor here. I'm importing SDIO and storage, setting up my NeoPixels. This is all typical CircuitPython running on that feather right there. Here, SDIO IO SD card setup on the proper pins with a pretty high frequency. I've got some error checking to make sure that the card is there and is working. And then in the main loop, I just check for CO2, temperature, and humidity values, print them into the REPL, and then I'm writing to that to the card if the card's available. You can see in my REPL right now the card's not there, so I'm just printing out an error. I should recover if let me eject this from my computer. Eject. Oh, it doesn't want me to because I have a file open on it. Let's try that again. Eject, okay. And now I'll plug this back in. One note, this has an SD card detect pin on it. The part we're using changed, and so it has flipped the polarity of that. I don't believe that is updated in Arduino yet. I think it is in CircuitPython and probably MicroPython. So if you want to check that little pin that gets closed when you insert or eject the SD card to tell the state, I don't think you can do that in Arduino, but you should be able to in MicroPython and CircuitPython. So now let's see in the REPL here. I'm going to see if it turns blue here to write. I may have to reset it. Yeah, it has not looked back for that card, so I'm going to just hit reset on there. So you can see, checks the serial number of the sensor, waits for the first measurement, logs that to my CSV, and there we go. We're back into the logging mode. So that's the example in CircuitPython. Now I just wanted to show briefly a MicroPython. All I'm doing here is blinking an LED, but this is running MicroPython, so I've just plugged in this other feather, and if I open it up in my editor, I'll go to the MicroPython drive, open main.py, and so this is MicroPython. It looks a lot like CircuitPython. I'm importing some libraries, time and machine, which is similar, I believe, to board in CircuitPython. So that gives me access to pin definitions. So I'm just printing out the name of the board there, and then I'm creating an LED on machine pin D13. We have a little link in our MicroPython section of the Learn Guide that'll tell you how the naming works, but essentially we're using the CircuitPython names, the silkscreen names, in MicroPython on this board, and those are strings. So you'll say, quote, D13 for pin 13, and that's blinking every half second there, setting it to out with machine.pin.out, led.high, high, sleep, low, sleep, repeat. And that's how easy it is to do a little MicroPython example. So slightly different from CircuitPython. I believe there are ways to use some of the CircuitPython libraries with Blinka. I have not tried that. If you're using MicroPython on this board, you probably have a very good reason to, and don't want to be using CircuitPython, and just know that both are options. Let's see. Let me see if there's any questions. Happy Hansa asks, has anyone ever tried to make a feather cluster computing project? That is an excellent question. I don't know of one. If anyone does, let us know in the chat. In fact, let me bring up the chat right here. Click, click, click. Let's see. DCD says, no worry, I was just curious about the SWD. Thanks for explaining the connection on the bottom of the board. Yeah, some of our boards, like, I want to say Grand Central was one I remember programming with the programming header that was built on. I believe that may be the case on the Fruit Jam. So some of our boards do have the programming header that we assemble at the factory. This one, to keep it flat, keep it low, this just has that SD card reader on the bottom, so it's pretty svelte there, and you can get that from the end, so you can mount this to something and still be able to access that, especially because it's a nice spring-loaded one, so you can click, pull it out, click, put it in. Let's see, any other questions? I will miss the boot user button. Yeah. This one, I suppose you could set up your own switch, especially if you're putting this on a breadboard, but I was just using a piece of jumper wire between the boot B0 and the 3 volts. When you hit reset or when you power cycle it, it'll check for that and put it into DFU mode, and then you can program it. But yes, it's definitely not as convenient as a boot button. Let's see, Alabama Cajun 7791 asks, can this one overclock with cooling? I do not know. I'm sorry, I have not contemplated that. Does anyone know about overclocking this board? Good question. Durpad IL, Durpadil, maybe that's your name, asks, just wanted to say the thumbnail is incredible on this live feed. Thank you. Yeah, for some reason I did one of those faces and took a picture, but then the big eyes in that are for some, I want to give a shout out to my friend Mark Fraunfelder, who had a tip in his The Magnet newsletter, tips and tricks. When he's traveling, he brings some high magnification readers to look at stuff up close. So I bought some 7.5x readers, which means I can look at things like that close, which is great for finding a splinter or certain electronics work. So that photo with the gigantic eyes was a composite of two and had the enormous magnification on the eyeballs. And it made me laugh, so I'm glad you liked it. Let's see. Made me laugh out rough. I really appreciate that. Okay. I think that covers the questions. So I think that is going to do it. Let's wrap this up. So I'll unplug this one right here and let you know that that right there is the product pick of the week this week. It is the Feather STM32 F405 Express. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Bye-bye. Ooh, look, there's still 3 left in stock. Hurry.